Welcome back to IDIS 343. Now, over the last few parts, we've built up the news vendor model, walked through its extensions, and set up the lot size reorder point framework, the Ch4 continuous review inventory system. Today, basically, we put all of it to work by solving an example problem. Now, picture a little boutique called Taste of Europe. Sophia, the owner, sells this premium truffle-infused olive oil from France, and while the sourcing is slow, the lead time is a full year. Each bottle costs her $15, and with a 20% annual interest rate, the holding cost H comes out to $3 per bottle per year. A stock out costs $30 in lost goodwill. Placing an order runs $40, and demand averages, 400 bottles a year with a standard deviation of 60. Demand is normally distributed, and our job basically is to find the optimal Q and R values. All right, we start by ignoring N of R and computing a plain EOQ. 2 times 40 times 400 divided by 3, take the square root, and that gives Q0 of about 103 units. Then equation 2 says, 1 minus F of R equals QH over P lambda. Plug in 103 times 3 over 30 times 400, and you get 0.026. Now, F of R sub 0 is 0.974. The table gives a Z of 1.95, and R sub 0 equals sigma Z plus mu, 60 times 1.95 plus 400, which is 517. Last piece, the loss table, L of Z is 0.0097, which makes N of R 60 times that, 0.582. Now we loop. Q1 uses equation 1 with N of R inside, 2 lambda times K plus P times N of R all over H, and that comes out to 124. Is 124 close to 103? Well, no, we keep going. 1 minus F of R sub 1 is 124 times 3 over 12,000, about 0.031. The Z drops to 1.87, and R sub 1 is, 512. The loss table now gives L of Z of 0.0119, N of R becomes 0.714, and Q sub 2 lands at 128. Still moving, 124 to 128. All right, one more pass. Well, round 3, 1 minus F of R sub 2 is 128 times 3 over 12,000. That's 0.032. The Z is 1.85, and R sub 2 equals 60 times 1.85 plus 400, which is 511. Now compare. R went 512 to 511, Q went 124 to 128. Successive values are, within about a unit, and we stop. The policy is basically simple to state. Whenever inventory position hits 511 bottles, Sophia orders 128 more. That's it. Order 128 at 511. None of this works unless you can read the tables, and there are 2 of them. Table A1 is the standard normal curve, the areas between 0 and Z. Now take F of R of 0.974, for example, subtract 0.5, look up 0.474 in the body of the table, and read the Z of the row and the column, 1.95s. I mean, the table is just a bridge between probabilities and Z values. Master that one move, and the rest is arithmetic, right? And the second table is the standardized loss function, L of Z. It answers basically one question. For a given Z, what's the expected shortage per unit of sigma? Find Z equal to 1.95, and you read 0.0097. At 1.87, it's 0.0119. Multiply by sigma, and you've got N of R, the expected stockouts per cycle, exactly the piece that feeds back into Q. Well, that closes the loop. Start with EOQ, then bounce between the 2 equations until Q and R settle down. Now, next time we'll look at service levels in QR systems. Thanks and gig 'em.